Hello everyone, and thanks for joining me. This is not an actual Handmade Hero stream. We will be getting back to Handmade Hero shortly, but I wanted to give a overview of an internal tool that I wrote a long time ago, many years ago, at RAD for basically debugging video codecs. It's the kind of thing that if you've ever tried to work on something like a video codec, then you kind of know that a regular debugger doesn't work very well for it because the things that you need to figure out and see are very hard to get the debugger to actually show you. And my point of doing this demo is really not to show anyone how to debug a video codec or anything like that, because I think that's a pretty specialized field of inquiry, certainly. But rather it's to give a demo of what I think were some pretty cool things we made for this purpose to show, in a sense, just how, I don't want to use the word bad, but just how little debuggers have actually done to get us what we need to debug things. If you think about what a typical debugger provides today, it's basically exactly the same thing that a typical debugger provided in 1975 or something, in 1985, let's say. It really just doesn't have the ability to do almost anything else. Now, some debuggers have added a few features that are new and are good, such as being able to step backwards or checkpoint runs in memory. This is a great feature, and I'm really glad that a few debuggers have added it, GDB and WinDBG being two that I can think of. But if you think about how little you can really point to that they've added in 20, 30 years, it's kind of too bad, because debugging is very important. Software today has just as many bugs, if not more, than it used to. And furthermore, one thing we know for sure is that software today is much larger and more unwieldy than software was back in the 1970s and 80s, because computers today are much more powerful and can run much larger software. And so what I'd like to do is just show what is possible, even with an internal tool that has not had many man years of development behind it or anything like this, and just to try to provide a little bit of inspiration for people working on debugging tools to say, look, there is a lot we could be doing to make debugging faster, easier, more powerful, and able to find very difficult bugs in as easy a manner as we are currently finding simple bugs. We just need the tools, and no one's really providing them. Obviously, I'm hoping that the RAD debugger comes online soon and that it will have some of these. RAD has all the source code to this tool because I wrote it for them. And of course, the techniques that I'm going to show in here are not rocket science. It's not like you have to have some kind of crazy knowledge of weird algorithms to do it. It's just a question of having sat down and doing it. So I think even just showing what some of these are, it should be immediately obvious how people who are making debuggers could add these to the debuggers. And furthermore, this tool I'm going to show you is not itself a debugger, which means that if you were implementing these sorts of features inside a debugger itself, you could make them even better than the features that I made, because you actually have process control and access to the debug info, which is not something that we had when we were doing this particular tool, because it was meant to run alongside an existing debugger that was doing those things. So that's really the only point of this stream, to sort of provide an example of what sorts of things you can do if, in a debugger if you actually wanted to. And so let me just go ahead and sort of show you how this thing works. And I wouldn't recommend using, oh wait, we're not in meow hash. Here we go. I honestly wouldn't recommend the UI to this tool. It's not good. There is one part of it that's good, but most of it's awful. So I'm talking more about the features here. Oh, I didn't know there was a whiteboard already. Okay, well, we'll clear that. I didn't know. Let's clear that out. Yes, clear the entire whiteboard. So anyway, I wouldn't recommend the UI at all. It's not good. So don't try not to take any inspiration from that if you can. It's mostly bad. There are a couple things in it that are interesting, and I'll point them out, but other than that, I think most of the UI is just a bad idea. And also, as you'll see, it's one of the reasons I'm not that into visual programming. It just ends up, especially if you already know how to do non-visual programming, it just ends up not being that good. All right, so let me start by explaining what Moustache actually is. So I'm going to open up just our regular editor here. This is for Coder. And I'm going to talk a little bit about what Moustache actually does. So you can see in here, you'll have to, I'm in the middle of some for Coder upgrades, which we'll actually do some streams about too. So you have to excuse my horrible colors. I have some debug colors set to see if my new syntax highlighting I implemented works properly. So yeah, the colors ain't great. But if you look in here, you can see a example program that I'll sort of point out how Moustache is designed to work. So basically this entire program is just a regular program. It's anything you want. So you can imagine having your own program, whatever it is, doesn't matter. And the only thing that makes it Moustache enabled is just including this one header file. If you include moustache client.h, you get all the features of Moustache. And again, this is really important. I'll just harp on it for a second. If you're going to make a debug tool, it has to be easy to use, and there's nothing easier to use than literally just an H file that you just include. Don't make me link with a library, don't make me open a DLL, don't make me do anything, just include one thing and then let me access all the features. I've said it a million times, it's just that's very important. And that way you just have to copy one file into your project, moustache client.h, and you just pound include it when you want to use it, and that's all there is. All right, so what features does this moustache client.h give you? Well, the theory behind Moustache was printf debugging is really great in one way, right? You all know printf debugging, right? It's when we just start dumping things to printf, and then we try to find the bug by seeing what we printed out and figuring out like where the crash happens or something, right? Well, the observation behind Moustache was printf debugging is actually really good in some sense. And the thing that it's really good at is it provides you a log of what happened. And this is actually something that debuggers are very bad at, right? A debugger shows, you're stepping through it, your brain is the thing that would have to remember the log of what happened. And if you're talking about millions of lines of code having executed, you can't watch all that. So the thing that printf debugging is really good at is sort of creating this log of what happened. But then the question is, well, why don't we just always use printf debugging if it's so great? And the answer is because modern programs are way too complicated. You just have reams of printf and it would just become exactly as complicated as having to step through the whole program. That doesn't get you anything. The thought behind Moustache was, what if Moustache could build a printf that was actually far more powerful and did two main things? One, it could print anything, so not just text. It could print images, it could print matrices, anything that you wanted to that was structured, it could actually print that. So instead of just a blank log of stuff, it could print data as well, and that data would be understood. That's thing one. Thing two, and that solves the problem of how do I printf an image, right? If you're just using real printf debugging, an image is just a stream of numbers. It's huge, it's massive, you can't make any sense of it, right? Well, solve that problem this way. So data size solved this way. But thing two, which is complexity, how about we make it so that the logs can be spatially queried based on the memory that they affect? So for example, let's suppose we could do a ton of printfs to say what happened to things, but as we were doing them, we said which pixels were being operated on, and then we could just query that one pixel. So instead of 1920 times 1080 times every step in the process being how many printfs we have to look at, which would never work, instead we just click on the one pixel that's wrong in our video, and it would just show us all the things that happened to that pixel, right? Then it's like shooting fish in a barrel. Oh, I see. It went through this transform and that transform was wrong or something, right? Does that make sense? So that's the idea behind this tool. And so you include Moustache client, and then what it gives you is a printf called stash f here, which you can see. And stashf itself is a thing which implements printf in a way that provides all these features. So for example, you can use it the way you would normally use it, meaning if you just switch a printf to a stashf, it would do it, right? So you don't have to do anything different there. But then it also has some other things. You can also see some things here where we talk, you can use it to like get input back or things like that if you want to, like a scanf as well, but that's sort of a separate thing. And not particularly relevant. You can also do like nesting in groups and stuff like that, so it has a few other things. But mostly the power comes from being able to do stashfs like this. And you can see here that when you do a stashf, you can say, I'm going to print something like a matrix here. And then you can pass all these sorts of things to it that are like more complicated. So you can pass like the width and height of an image or rectangle, and then like you can pass some plane data in. So here are some of the planes of the image. It'll gather those up. You can say like what format they're in, like unorm or whatever, right? Different kind of styles of things that you want to talk about for pixels. And so you can do some of those things. You can issue breakpoints, which are basically saying if I get here, stop everything and wait, in the tool when you're viewing these things. And then we also have some stuff, like I was saying, for tracing. I use the term deep memory for it. And the reason that I called it deep memory is because basically it allows you to write to the same sort of pieces of the log. It allows you to say, look, as I move memory around, I'm going to tell you where I moved the memory to. Like if I do a mem copy, I'll tell you that, or I'll point to the memory that I'm referring to. And then when I printf into that, if later you're ever trying to inspect something that touches that memory, go pull all of that history back so I can see all of the steps that the data went through to get to where it was. And so the way that that works is things like this. So this thing is a stashf that says, oh, here is a chunk of memory, and I'm transforming it to this other chunk of memory, and you could pass these two things here that specified it, right? And so when any time you did a stashf that related two pieces of memory together, it would know it could search back through that chain. Again, for some reason, we were really probably overly specific about always making everything go through stashf. So there's like one function, it's just that one. Probably wasn't really necessary. We probably could have called this stash copy and not had it imply that two things that happen on the same line are related. You can see why there's some things I say like maybe don't copy the user interface, either the API or that, because this was not a shipping project. This was internal only. So you can do other things. You could have diagrams here, right? Like here's an ability to just draw on top of a diagram, on top of an image, right? You could just say like, hey, I'm going to start drawing on top of this thing that I just output, right? Like here, and things like that. So, it's got other features in there that weren't printf based, where you could basically use like OpenGL essentially to draw things to it. And it just goes on, right? So, lots of things you can stashf and so on. So this is all, again, just regular code. You could do this anywhere in your project. You could just call this stashf thing, and that would be it. And again, the only thing you had to do to enable that was include Moustache Client. Now, Moustache Client, again, is just a header file that implements this stuff, right? So it gives you all of the structs you need for this, and then it has the code necessary to do socket transmission, right, out of here. And it worked on like it worked on the Win32 and on Xbox 360. I don't know that it worked on PlayStation ever. It might have. I can't recall whether anyone actually tried it. We probably did, but don't quote me on that. So anyway, once you have a program that supports Moustache and is going to do the debug output to Moustache and you want to use it, then the way that it works is you run this little server, and in fact, this window is not really that necessary in a sense. What actually happens, and you can't see it, I could make it so that you could see it in a second here. Let me unlock this taskbar. There you go. So you can see that it creates a little mustache icon up here that just sits in the sys tray, right? And then if you run a program like that Moustache client test that we had, if you run a program like that, what it would do is it'll actually, oh, I have no idea what that is about. Okay. It's basically complaining it couldn't find one of the source files. Maybe I didn't copy it over, I'm not sure. But anyway, once you run one of these things, it runs. And if this thing was running, then what it would do is it will capture all of that output. So you don't actually have to be aware of Moustache really in general. It just kind of sits there and captures everything that you dump to it. Now, this had input and output and breakpoint testing in it, so you can see that this program hasn't completed. The reason is because it's actually waiting for Moustache to tell it it's okay to complete. But if you were using a program that wasn't testing input and output or didn't have input in it, it would have just completed and Moustache would save the data. And in fact, we can, if we want to, just kill the app, and that's fine. And then I can run it again if I want to. I can run it as many times as I want, and so on, right? Now, all of those runs actually get captured by Moustache, okay? So they're sitting in here waiting for us to use. Now, again, I said the UI isn't great. Let me show you how it works. What happens is you draw these little nodes here. Like I just drew where I wanted this new node to go, and then you can pick what kind of node you actually want. I'm gonna pick process list, and of course what process list does, all right, maybe I shouldn't have made it quite that big. What process list does is exactly what it sounds like it does. It lists all the processes that have been run, right? So here they are. And you can see all the runs of this program. Remember I ran it 3 times? Well, here are the 3 runs, right? And each of these processes is selectable. You can see like I've got them, and it tells me like when they were run, right? It's pretty straightforward. Hopefully this makes good sense to everyone. Now, I think there's a way in here you could filter, like if I only wanted like a particular thing, I could type like client, star client star, and then it would show me only things that match that pattern. I don't have different, I only ran like one executable name, so that's never gonna do anything. But if you had like lots of different executables and you wanted to just focus on runs of one type of executable, you could filter it there, which is kind of nice, right? So now, like I said, this is one of those kind of crappy visual programming language things, and don't ask me why I made it this way. I don't have an explanation. It's just, I don't know. But what you could do is you could connect any output of a node to like the input of any other node, right? So in this case, I'm, this thing is like a picker essentially, right? I can pick these processes from the list, and then this node is a thing that displays data about the process in question. So anything that you connect it to, it will look at what process ran it and tell you about the process. So this is nice, right? And I wish debuggers did this in general. This just saves all of the runs that I did, right? And it tells me what they were, right? It says, here was the process. Here's the executable that got ran. Here's how big the executable was, what the date was it, when I executed it, what machine ran it. Because this supports TCP/IP discovery and stuff. So if you ran this on another machine, it would connect to this Moustache server and give it the data, which was nice. It tells you what hardware it was running on and all that sort of thing, right? And it tells you how many threads outputted to Moustache as well, in case you were curious about that or whatever. So again, I haven't gotten any of the features of Moustache that I really want to talk about yet, but even just this, I don't have a debugger that does any of this, right? I don't have a debugger that just sits there and remembers runs of programs and allows me to like know what the output was of the programs, even to the console of multiple runs. I don't have any of that, right? So even just this basic first step is like way better than any debugger that I have, which is not good, right? This should just be par for the course. Computers have like infinite storage and infinite memory these days, like remember everything, right? And Moustache did. It remembered absolutely everything you ever did. You could go right back to the first run of Bink 2 and see everything that it outputted. And why don't we have that? That should just be how debuggers work. I'll buy a bigger drive. I'll keep throwing 8 terabyte drives at you to store my data, right? Okay, so But that's not that interesting, right? Because all that's telling me is some basic things about a run of a program. What I want to do is start looking at like what that program actually output, right? So we have a node called listing, and what a listing node is a node that if you hook it up to any process that you've selected, right, then it can tell you what that thing output. So this is the actual output from that program. So every time that you called stash f, this is what was there. This is all the stuff that was in stash f. And so what you can see here is that this program, and actually all of them, stopped on that line, right? And I can pick these programs separately, and we can see them. And you can see, like, so if I jump back to this program, for example, I don't know if it actually, one of the things that's kind of annoying about the way that Moustache happened to work is we didn't patch in an exception handler to it. So if you control seed and it hadn't flushed the buffer yet, you didn't get the buffer. So there's a couple things like that like aren't great. But what we would do is in our program, we'd just put a catch-all handler around the whole thing and call stash flush in the case of a crash. So in these where I controlled seed it, we may not have gotten the data, which is less good. But that's just, that's just how it goes sometimes. You could do better than that. You could do better than what we did. So I believe here where we're outputting these things, this program is paused. You can hit F5 inside Moustache, and you can see like it will output, like that's how you continue the program. And again, that was if you put stash breakpoint, that's all that is a thing that's there to try and let you stop in Moustache when you want to stop in Moustache, because we would have situations when we were working on Bink where we're like, okay, we want to get up to this frame and then stop in Moustache. So that's what that was. And the little red bar is what would tell you that. It was like, this was a thing where we stopped. Now, you can also drag this little weird nub here over to look at information about the thread. So when Moustache outputted this information, this was the processor that the thread was running on. So for example, this is running on processor 2. Processor means logical processor, so in this case it means core 2. Obviously there's only one processor in this machine. And this was the thread ID, which is thread ID 58. Now there's only one thread in this test code, I think, if you don't call the thread test, which I don't think we did. So it's always going to be thread 58, but the processor jumps around because, hey, Windows can jump us around anywhere it wants to. We didn't try to lock down Infinity or anything. So here's all the printf, and as you can see, like by default, all Moustache will do, if you just have a listing node, is just give you a printf. That's not very interesting, but it is, what Moustache does, right? So you got that basically in there, and it's a little bit better than a printf, right? I can collapse things, right, and stuff like that. There's some weirdness. I don't remember all the key combinations. There's like some key combinations you can use to like collapse stuff and not have to do what I'm doing here, where you have to like scroll back and forth. And I really just don't remember what they all are. So some of this stuff is you would want there to be mouse input for, and we don't have it. So I apologize for that. I'm going to get into situations where I'm like, I don't know how to fix this thing. And so that's my fault. But point being, there's a bunch of things that can sort of do that are different from a regular printf, but that's not that important. It's fun to have collapsible things, and they're good for certain situations, certainly, but that's not one of the more interesting parts of Moustache, certainly. So there's a couple of the things I might go ahead and show you as well here. So this was one run of the program, right? And I don't know what the status of this is here, but let me see if I can recompile Moustache client test.c as well. So it needs like what, like winsock. So I don't remember winsock.lib. Winsock. What's winsock's library handle? Anyone? Winsock lib. Is it wsock32? wsock32.lib? Maybe? I'm not sure. Okay. And then we just need like, user 32. And, advappy. Who's the registry? Yeah. Get adder info. Maybe we need the other WS232. There we go. Okay, so I can compile the Moustache client on this machine. You may ask, why do I bother? We already had a running version of the Moustache client. Well, the answer is because I kind of want to show this other feature. I may not remember well enough how to make it work, but I'm going to show it, or attempt to show it to you. If I go to Moustache client test, and in here I say like, oh yeah, the define foobar is the thing. One, I'm gonna make that happen, and then I'm gonna recompile this client, and then I'm gonna run it again, right? So now what's happened is you can see we have the one from 10 minutes ago that's there, and then we've got this new one. What I'm going to do is I'm actually not going to switch the process list. Now I could, right? I can switch the process list to get to the other one here, right? And then I can, do my F5 or whatever like that. I'm actually not going to quite do that. What I'm going to do instead is I'm going to leave this one set looking at this one here. I'm going to make a new process list to grab from here and a new process node as well. And I'm going to select the new one in here. So that way I've got both of these. Now I could also just use this latest process Boolean you can turn on, and the latest process Boolean would just automatically pick that. I wouldn't have to have a process list. And that's what you would do if you wanted to just always have the most recent run of the program in one of your flows. So that was also a common way that it was used, but we'll ignore that for the moment. Now I'm going to go ahead in here and say, all right, there's a listing, and the listing is just like the one we had before, but now it's being driven by this node. So now I've got two different listings, right? Okay. Now the reason I was saying I want to have two of these, two different runs of the program, and have a different compile is I believe there is a thing, and again, I may just be like, oh, it doesn't work, never mind. There's this thing called source diff. And what source diff does is if you hook up a process to it, and then you hook up another process to it, it tells you what the difference was between the two runs, okay? So you can see here what actually happened between these two things. So you can say like, okay, there were two missing files, 21 lines matched, 5 differences were found. These files were missing when we tried to do them, and we switched out these versions, right? So used to be the old Moustache client test, and now it's the new one, right? Who knows, right? Okay, of course it does. I don't make any promises that this thing will run reliably. Wait, how come it didn't? Yeah, there we go. Let's try that again. All right. So anyway, what is it doesn't like the scaling on that? That's interesting. It doesn't seem to like, is that who is having a problem with scaling? One thing I will note is that this thing is a lot more crashed than it should be, because I had to write all of the graphics by hand because Jeff didn't want me to use GL for it. He felt that like GL was too unreliable, so this is all handwritten in GDI, so like the stuff that actually renders images and stuff is written by hand, and it's in a short period of time, so it's pretty error prone. Even the clipping and all that stuff like had to be written by hand. It was not fun. Anyway, so there's like an entire custom graphics library just to support this thing, which was and is, anytime you have a little off by one in there, it's it's not great. Anyway, so I don't know why I'm getting that problem. It looks like that diff node is buggy. So anyway, again, apologize for all the bugs and all that stuff, whatever. Point being, the interesting thing about that was, and the reason that I wanted to bring it up, was because another thing that I wish debuggers always did is just save all of my source files from that run. And Moustache did that. So inside the Moustache file, in addition to all of the data, it also saved all of the source files, so that what you could do is, if you needed to know what files had changed between the two, you could do that. Now, we never really built out full diffing utility, which would have been great. That was kind of one thing I wanted to do and just never did. But you could easily see why this would be good. If you have 2 runs of a program and one of them works and one of them doesn't, you can just quickly see what were all the changes, right? And so that's all that I wanted to point out there. And so I just think debuggers should always do that. In fact, I don't understand why PDBs don't store all the source files. They obviously should, in my opinion. I have no idea why they don't. Because that way you wouldn't need to worry about paths to source files. The PDB would have 100% of the source that was ever used to create that program. Because if the compiler could read it, it can be in there, right? And so the only things the PDB wouldn't have is like libs if the libs didn't have source in it, but put it in the libs too. Put all the source in the libs, right? Put the source in there. Every time you compile a program, put all the source into it, into the debug info, right? That's what I would do. So Moustache did the best it could to sort of have that for you. But really, again, I think that should be the debugger's job. All right, so let's move on to the actual like more useful features for stuff like this. Okay, so let's suppose that we want to do something like in one of these listings. I guess I'll look at this one here. Let's say we want to take a look at like this. What's a good example? Large image diff test, let's say. So if I go ahead and create a thing that does an image diff, I'm not sure if I'm going to do this right, so you have to, again, bear with me. But what I want to do is I want to see the difference between 2 images. So what I can do here is say, like, all right, let's grab 2 images off of this listing. And so, maybe in here I could just say, grab this one, right? And one of the weird things about Moustache is nodes remember their settings. So I think if you just do that, it keeps it. So I can actually grab these like semi-permanently like this and then disconnect them, right? Which is kind of weird, but that's how that works. Anyway, I can also just have it be live. And then when I switch these off, I get different images, right? Whatever. So anyway, these things show the images, and of course you can zoom in on them, right, and look at them however you want to, and it's all live and nice and all that nonsense, which is fine. And then what you can do is the data that comes out of those, I don't know if this works right. I think it does, maybe. Yeah, I don't know. Maybe it doesn't, maybe it does. This was the first one, and this was also the first one. You can see 0, right? But if I switch it to the next one down, it'll show me all the differences between those 2 images, right? So I can just come down in here now and look at a particular place that's different, and off I go, right? Which is pretty nice. And one of the nice things about this too is that, again, this is all live. So if I wanted to, I could make this thing here say always use the latest process, forget this, just use the latest process. And then every time I ran the program, this would automatically update for me, right? But this, because it's not connected to anything, would always diff off of this image. So I can store old images right in the Moustache whiteboard and just always get diffs off them, and it all just works, right? Which is kind of nice. And again, you don't need any additional storage. It's just that one directory of Moustache files keeps everything. It doesn't need to be able to get back to your executable or any of that stuff. It packages everything up into the runs. All right. So that's how that works, right? You can see why that would be kind of nice, right? You can see stuff. These diffs also have some stuff like the peak signal to noise ratio, the root mean squared error, stuff like that. And you can also crank this multiplier. So this allows you to go down to this is the actual difference, right? But it's kind of hard to see if there are some differences that are not very high. So this multiplier just let you crank up those differences to make them visible, right? And again, that was a nice thing. So the other cool thing you could do with that is if you wanted these differences to be displayed against the backdrop of an image, because you see this, you're like, well, I don't really know where those are as far as where on the video frame they were, right? So there was another thing you could do, which was called a node overlay. And again, I apologize if I screw this up. I don't remember much about using this tool. And the node overlay could basically say, well, look, take whatever the image is that I give you here, like let's say this one, and allow me to pipe in another image to show as the image that was on top of it, right? Oh, I guess this doesn't allow that though. I thought that you could do that. The problem is this is not transparent. So I guess that's not true. I don't remember how we did this then. I think there was a way to do this, but I guess that's not it. All right. Forget that. I don't know how to do it. Like I said, I don't remember, so I couldn't tell you. Let's me disconnect that there. How did we do that? I don't think there was some other magic thing. Maybe that's not how we used to do it. Yeah, I don't know. All right, I apologize. I don't really know. I'll try some other things in a second and show you those instead. Anyway, so let's talk about a couple other things before I go down into the actual more interesting features than just image diffing and live stuff like that. So one of the things that I thought there was one and only one good UI feature of Moustache, and that was these things here. So let me show you what those are in case anyone out there is actually doing a visual programming language or node-based thing. These things are awesome. So here's how they work. If you click on the middle one, it will drag anything in that set of nodes, right? Which is awesome. So if I want to move this collected set of stuff, I just do that, right? And it moves everything that's connected to it. That's super handy. If I do this, it moves it and the downstream nodes. So it's the same thing here, right? But notice it doesn't pick up this because those are upstream. You'd have to travel upstream. So all of the things that are descendant from it can be grabbed this way. Similarly, any antecedent node can be grabbed with the other one, right? This was just a really easy way to reorganize stuff. I don't know why no one's done it. I don't know if they just never thought about it, but it's super handy. Maybe there is some tools that do it. I don't know. Maybe the blueprint in Unreal Engine does it. I'm not sure. Anyway. That was one really cool feature that I highly recommend any visual tool do, and it was pretty cool. All right, anyway, there's a bunch of things you could do for whiteboard control, and I'll show you some of the neater ones as well since we're on that topic. So let's suppose that really all you wanted at the end of the day was this image diff. Well, and maybe a couple other things too. Like I want, this listing and that diff or something, and that's all I wanted to see. Well, the base whiteboard kind of has everything on it, but you can also have other whiteboards. So here's like another whiteboard, and I think you can name them. So here's my foobar whiteboard, right? And what you can do is you can just grab pieces from your existing whiteboard and make them into their own layout. So these are now like, and I think you can also, I thought there was some way too to like toggle the, sorry, I don't actually remember. I don't remember, I think you could shut off these ghosts as well. I just don't remember how that was done. So anyway, if you take a look, maybe it was something up here. Oops. I don't know. I have no idea. Anyway, so you could create your own custom views where like, you create this big weird graph that gives you something you want, and then you could just flip over to a different view. These were all, they weren't cloned, they were actually the nodes for real. So any edits that you make back here would work when you switched back here. So it was a really nice way of basically having some custom view panels that just worked. And if I remember correctly, this actually works cross-monitor too. So if you have another monitor, right? Oops. How do I get, what's going on here? There we go. So if you had another monitor, you could go ahead and put like two different mustache views, one on each monitor. So here's the live updating of number 2, right? But then if this one's on number 3, right, then you edit them separately. So you could pretty much just have this your console set up exactly how you want it, with many mustache views showing lots of different things at the same time if you want to. And that was pretty awesome. Again, something I wish debuggers could do, and they pretty much can't. All right, so moving on to more features. So a couple different things. And again, I apologize for not really remembering how most of this stuff works. So here's a node overlay, and it's coming from this image source here. What if I want to start talking about pixels in there and looking at them in more detail, right? So we have this thing called a pixel inspector. And what a pixel inspector does is it takes a particular X and Y location and tells me more about it. So if, for example, I wanted to know, in this particular image here, let's say, oh, and actually let's do it to this one because this one's hooked up to an active so I can swap them around. So let's say I take this thing here, right? And I want to know more about a particular pixel location. Now, this is going to expose a bunch of mustache features at once, and so you'll have to kind of bear with me as I walk through them in series. It could be a little bit hard to understand everything that's happening here. So let me zoom in on this, this node a little bit, right? Maybe let's move that out of the way as well. All right. So here's my pixel inspector. And you can see, like, it's coming from this listing. I can pick different matrices here, right? And I get different results. And what you can see is if I, in here, was to take the X and Ys that I want to view here, it will tell me for a given X and Y coordinate, it'll tell me what the information is about that particular pixel for that particular image. Now, it's annoying to try and pick pixels by hand. Sometimes you want to do it that way, but sometimes you don't. So we have this thing called a pixel picker, and of course you could wire it up to anything you wanted. So you could have like an XY coordinate, you can see here, and now as I move around any particular XY, it will tell me what that particular pixel was, and it'll tell me all about it. So this is the transform, the color transform that's going through, which is the unity transform, but you could go through a YUV transform or something you want to. It's telling me what 32 by 32 block it's in, what 16 by 16 block, what 8 by 8, and then the actual pixel location. It's telling what its value is in real and in UINT, just, you know, because these are things we want to see. Again, this is for video codecs, so we want a lot of information. And now I can show you, I think, the overlay, the node overlay a little bit better. Don't ask me why it didn't work with Diff. I don't remember. But if I go ahead now and say, oh, take this image source here that I'm doing and make that be from the overlay, take the pixel picker itself. I'm trying to remember how this works. Oh, God. This is one of those things where, you know, at the beginning when I said don't clone the UI for this, this is why. I've done this horribly wrong. So the overlay takes the pixel picker so yeah, this is one of those things where you're just like, I know there's a simple way to do this, but is it this thing? No, that's just the outliner. I really wish I could remember what the heck goes on here. There's so much stuff in this program, it's ridiculous. And trying to remember all the stuff there's, let's see. So there's all of that stuff. I was pretty sure I could do it with the things I had here. Pixel picker, pixel inspector, pixel outliner. And how did you get them to like overlay? One of these things does it. See, Pixel Outliner doesn't have any way to drive it there. Hold on a second. I'm gonna do some weird stuff here. So here's the pixel picker. I'm gonna connect it to the outliner. This program is so nuts. Right, so that does exactly what you would think it would do. Oh! Right. The node overlay is coded such that you don't have to hook up an image. You're just hooking up anything from that node. Yeah. So all I have to do is just drag like the X over here, put that on top, and then it shows up, right? And since the node overlay overlaid the UI for the nodes as well as the nodes, you can see I can get the picking happening there as well. Yeah, got it. Okay. Like I said, don't clone the UI. Anyway, so I can go in and look at like particular ones here, right? I can look at like this one or whatever, right? And I can look at the pixel inspector, and I can see what the status was of that node and all of those sorts of things, right? And so once you set these up the way you wanted, like I was saying, you could get to a nice point where you did all your crazy wiring, which is the part that I don't think was very good. I think you'd rather just maybe write some expressions or something that say what you want, and then it puts up just a UI that just lets you do that, you know? But anyway, you have to do your visual programming, you program the thing, and then you can get what you want, which is here I can like do pixel inspection this way, and also I can have as many of these inspectors running as I want, so I can inspect the same pixel location if I want to, for example, on some other image or things like that, right? Okay, so again, still not that, I mean, it's nice to have all this stuff live. Again, if I just run the program, this would all just update and all that stuff, and I can, again, diff with old things, and all those other sorts of things are great. But again, still not really the most useful parts of Moustache, even though all of them should be things that you would want in a debugger. The far more interesting stuff comes when you start to look at the, like if I go in the what's the word for it here? If I go into the listing, looking at some of the features that allow you to sort of work with data associated with memory. And so one example of that is a thing called an MSpace. And what an MSpace is, it's a thing that allows you to associate printfs with regions of like an image. So for example, if I go here and I say like, show me, you know, I'm gonna pick an MSpace here. So let me get rid of this. Let's go ahead and say, grab this MSpace that I've got and pipe it into here. It should tell me that I've got a title for it. I don't know why I named it Filet. Filet and Ribeye were the two I named for some reason. And it's a 1920 by 1080 output is what that MSpace was. Maybe I'll move this over here and just put this in line with it. And then if I want to, this thing can be viewed, if I'm not mistaken, as sort of its own thing. Don't necessarily recall how that happens, but I think it just works like this. So if I'm looking at this MSpace, you can see what's on it here. And if we take a look at the image that was paired with it, so like here's the MSpace there, and I'm going to take one of these image sources like this one. Oops. And I'm going to go ahead and pipe this guy to that. So there's that image source coming through there, and then I'll disconnect it. So it's just permanently listing that one. And now we're on this other one here. So here's the image that the program printed, and here's the MSpace that was printed after it, which is basically just printfs that can go to any part of the image. And it happened that this one was going to print, this one prints regular tiles of stuff. So you can see the MSpace here, you can see the image source. I've overlaid the MSpace onto the image source, right? And so what I'm going to do is I'm just going to zoom in, and you can see the logs start to appear where they went, right? This is actually just a printf log. So you can printf anything you want into an image and have it show up at that place on the image. And this is super powerful because like for things like video compression, for example, it shows you anytime you had bugs in a particular case, like let's say you had case 13 of your motion compensator was busted, you could just printf into the tiles that thing actually affected, and then you just zoom in on the one that was wrong and look at the printf log, and you could see exactly what happened, right? Furthermore, end spaces, I believe, are queryable. So for example, if you go ahead in the pixel inspector here, I don't know if you can do this, probably not. Nope, you can. So if you look at the pixel inspector, you can actually look at all of the things that are actually connected backstream. So for example, if I click on this particular pixel, I will get all of the MSpace logs that have ever happened in this chain to that location, right? So I can just say like, oh, tell me the MSpaces that overlap this pixel, and it will print them out for me, right? And again, that allows me to keep stacking those up if I wanted to. So for example, if I wanted to look at multiple MSpaces at a time, I could also do that. So for example, here's another listing node. We'll grab the same, grab the same process here. And I'll go look at, what are we doing? Fillet here. We'll look at ribeye here, for example. If I wanted to have that one show up as well, off we go. And you can see that that's a different one, and it's at a different resolution. And again, there it all is, all shown in there. And so now, if I'm like zooming around here, I'm like picking what affects these pixels, you'll notice that there's nothing from that one, right? There was nothing in there. But as I come back here, you can see now there is. So this shows all of the MSpaces that could possibly have affected that. Now sometimes there's things like node overlay, it's just taking up space. Well, I can choose to turn this off. And so what I do there is I just say toggle node hidden from inspector, and then it's gone, right? So I have ways also of controlling what shows up in the inspector if there's certain nodes that I don't want shown in there, if that makes sense. Okay. So again, really kind of handy the way that stuff works, and you kind of get this really nice sort of ability to just zoom around images and find out what's going on with them and all sorts of stuff like that, and so on. Now, the other things you can do is you can start to use features that analyze the data if you want to. And again, my memory is really hazy on how these work, so you'll have to forgive me. But let's suppose I want this image source to be analyzed in some way. There are other nodes that do that, and I don't really remember what they are. So minimum and maximum is an example node. And so if I hook this up, it'll just tell me, right, for the node that I was looking at, here's all the minimum maximum values that there are. Now there's a reason why there's like X, Y's, and Z's of these. I think that's because we just sort of had this notion that things could be 4 wide and we want to know. So those are like RGB or XYZ depending on what got fed in, I guess. Again, don't really remember how this tool worked very well. So, you can, do stuff like that. The other things you could do is you could put in like actual just stuff, code. So if you wanted to, you could say, well, take, this thing. Don't ask me if this is going to work. I'm just randomly trying this. I think it might. I don't know. But like, okay, I want to look at this image, but I want to look at the image. Does it work? No. Not sure if it does or if it doesn't. Oh, well, this is an image source. So maybe I just need to do one of these or something? I don't know. All right, maybe not. So again, you'll have to forgive me. I don't really remember how a lot of this stuff works. So this thing knows it's one of these as an input, but I guess it doesn't output an image. I'm not sure. But anyway, inside the input field, I think you can just type stuff. Yeah. So if you wanted to change something that was coming in, you can put a like a scalar value in there or whatever. I guess I just don't know if it can flow through the pipeline. You would think, right? But maybe not. So for example, if that's, I don't know if I can inspect this. Yeah, so I don't know. That seems kind of broken. It may be that I just never quite finished those. I don't know. So I'm not really sure what that node was for, since the polymorphism of the types was maybe not as good as it should have been, because it should have been able to flow through, and maybe maybe I just didn't get around to having an anything slot. Nice idea, but I don't. Yeah, again, I'm not sure what we ever would have used it for. Possibly we never really did use it. Doesn't look like it really works. There's this thing called controls, and controls is just something that allows you to specify some values. Again, don't really know what this was used for, but I think in some sense it's if you wanted to have stuff that was sort of controlled from a central location. So for example, if you wanted a lot of nodes that had a Boolean, like let's say, or even a float. So let's say that you wanted all of your inspector nodes to use the same pixel scale. So what you could do is you could wire up something like the pixel scale of all of those nodes. So you can see here, like I'm looking at that, right? If I was to sort of change that value, it would change in that node lister as well, right? And so that's what that was for. I just don't really know if we ever used it much. All right, let me try to think if there's anything else in particular. Recent element and element gather, I don't think are particularly relevant. They're just things that gather things out of a listing. And the pixel picker outlining profile report, all that stuff these are for debugging only. Like this is just how Moustache is running at the moment, right? You can see what it's spending its time on, which is not particularly relevant. So I think that's most of it. Let me see if there's other things that I should be looking at here, just to show some of the other stuff. The stat test, image span test. So let me look back at the Moustache client code and see if there was anything else in there in particular that is worth looking at. So if I look at the image span test, see what that does. No, that just, yeah, that's just working with pitches and stuff. Are we, where's the deep memory test? So the deep memory test, are we not calling it? Oh, it was turned off. So I'm gonna turn all this stuff on and see what happens. Like, I don't know. We've come to the end of the demo, but I don't really know what this stuff does, so let's try it. All right. So here we are back at the process list, right? Yeah, maybe I'll clear this whiteboard. And we'll just go ahead and run this again. Moustache client test. Here's this latest one. Here's the process. Here's the latest process. I guess I don't really need the process list for any particular reason at the moment. And let me make a listing so we can look at it. So here is an example of Moustache input. So you can see it started doing the same thing it was doing before. And maybe I'll start to use Moustache like so we can kind of see how you might use it in practice, just to get an idea of it, right? So maybe one thing I do is I just have my like latest listing, right? And that thing's just going to be this node, and it's going to be this node at about this size, let's say. And I won't go over that thing here. And what I'm going to do here is I'm going to do a node interface lock, and I'm going to do a deselect of it. There we go. Wait, like that. No, that's not what I want then. Is this what I want? I don't know what some of these things do. All right, well, I don't know. Anyway, point being, I'm going to toggle the interface lock on, which means that I can always like interact with it in this view. And I believe if I go back to the main view, you can see that that's tracked separately. So it's actually, anytime I flip back here, this guy's UI will be active. And maybe I can open up the thread information here. You can see where each line of output came from too, which is kind of nice. So here, when I run the program, I get all of my debug output and, you know, whatever. When we get to the input, one thing I don't actually know how the input stuff works or if it works. I'm going to skip that part because I literally just don't remember. I think you could input values to Moustache. I want to say, but how? I don't know. You can see here it's asking for input. That's what the blue line means, right? Is there like a type this in sort of thing? Anyone know? I got nothing. So I think you could input values here. Don't ask me. I'd have to go read the source code. So I'm going to skip that and just hit F5. Here's an example of a breakpoint, right? Like we said, hit F5 again. Here we are at the structured art stuff. We're going to print that in. And so one of the things, too, you can see, in fact, here at the structured art test, let's go ahead and create another view here for a second. And what I'm going to do is I'm going to size this node differently. Again, really using the power here of Moustache. Like, this is the same node, and all of its state is the same, but I can position it and edit it differently, which is really nice, right? So I have different views for different purposes, and different sizes and all that stuff is just kind of really handy. So anyway, inside here, what I'm going to do is say, look, I want to look at the latest image. So I'm just going to do that and do it like this. And as I run the program, right, because remember, the program is halted now. Oops. I want to resize this guy. Oops. Maybe like that. There we go. So as I run this program, I can actually step back. You can see it kind of animate through. But also, if I say specific line false, so you can see like on here, specific line true. All right, maybe I don't remember. I thought there was a way. I thought there was a way to do this where it always picked the last one. Maybe it's this way. Yeah. So I guess if you want to, let me go back to the default whiteboard here, where this stuff is hanging out. So I guess maybe this is the way you were supposed to do it. I'm not sure. Again, it's been a really long time since I've used this program. I'm surprised I've remembered as many things as I did, and the UI is pretty bad. So if you connect a process and then you say, I want to find the most recent line, you can just attach that this example here, you just say, I want something that looks like this, right? And I'll be darned if I know how this worked, but I think this would basically match any time it got the line that looked like that. So that's not, all right, I don't. This actually is a search for something that looks like that line. So basically, if I ran the program again, it would find that line. That's not the thing I actually wanted, I guess. Oh, wait, no, it is. Look, it found frame 9. Wow, I don't even know how it did that. All right. So yeah, that is what I wanted. Never mind. Man, this program is nuts. All right, so anyway, now I've got the most recent element here. I actually don't need this in this particular view, which I'm not sure. I think I just called delete on it. Maybe it doesn't. Does that get rid of it? No, that gets rid of it entirely. Try that one more time. So I'm going to say recent element, and I'm going to grab this process. And I'm going to grab this line as an example line. And then I'm going to patch that through to this image source. Right? Again, super powerful program, just horrible UI. It needed like a lot of polish. Anyway, so here's that image source node now, right? And as I run, you can see that it updates every frame. And more importantly, let's say I kill this executable, like it's gone now, right? If I run it again, what you can see is that search is very powerful. This is a totally new run of the program. It figured out that that was what I was looking for and is now showing me the most recent line that looks like that line, right? So again, pretty cool. I don't know what this is complaining about, but I guess it doesn't know whatever that thing is. I guess those things were, I guess some of those things were if zeroed out because they were never implemented. I don't know. I have no idea what this thing is. This looks like it might be an infinite loop, so I may have to just turn this one off. The hypothetical compression example. So let me just recompile this here. There we go. And run it. There we go. So yeah, we'll get that just fine. Oh, that just keeps dumping images till you run out of disk space. Okay, that maybe shouldn't. Okay, I admit that I should not have enabled that. So maybe I just want this one because I don't know. There we go. Oops. Nope. No. No. All right, there we go. So I'm going to run through to the deep memory test. Here's the deep memory test. I don't really know what it does, but I'm going to try to figure it out. All right, so if we come back here and we look at this listing that's got the deep memory test in it. So what I'm going to do is I'm just going to inspect that image. So here is an image source node, and I'm going to look at that particular image, which is this, and see if this stuff works still. I have no idea, and I may just be using it wrong as well, so who knows. But here's the image source, right? And let me go ahead and grab a pixel picker and get one of those pixel inspectors going. We'll put that here, and we'll put this here. And I'll just grab a pixel inspector, and we'll do it like that. And we're going to inspect this image. All right, so I, again, don't really know if this works or not. We're going to find out. It may or may not work. So here's me like scanning this image with the pixel inspector. I don't see it reading any deep memory out of there. So I guess I'm not sure if the deep memory stuff just didn't end up getting moved over from the previous version of Moustache. I know this stuff worked, but I also maybe just am not doing it correctly. And it doesn't look like there's a node specifically for that. At least not that I can find. Yeah, so I'm not sure. I'm not sure how to get... I'm not sure how to get the deep memory stuff out. So I don't know if maybe the M spaces were just... we were using those exclusively and we stopped using the deep memory, so there isn't a node in here to view it anymore or something like that. I really can't remember. It was working at one point, but I don't know if it's actually working anymore. I'm assuming I can't view this as an M space. Yeah. So I don't know. I don't know what the deal is with that. It may be that that got pulled out and for some reason wasn't in there, or it may be that I'm forgetting the way that you actually do it. Again, because the UI is so janky, it may be that it's just like, yeah, you need to do this other set of things, didn't you know? And then you can actually see it. If you look inside what the code says, it looks like it's going by 8x8 blocks, right? And just, yeah, I mean, it's pretty clear what it's doing. It should have just... I mean, that should have just been able to gather this stuff up when we look at a particular image. So I'm not sure. Unfortunately, like, I just don't remember the code well enough to really remember what was going on there. Or I'd go look. I'm pretty sure... Let's see here. Raw file, direct, whiteboard. Where are we at? Plot, process, blah, 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 blah. Yeah, I don't see any... I don't see anything for it, and so I don't know. I'm not sure where it goes. There was a previous version of Moustache that definitely had deep memory implemented, and I thought this one did too, but maybe we replaced them with M spaces because that's all that anyone ever used, and then I never made the node to actually look at deep memory. Which is unfortunate because deep memory is cool, although it basically does the same thing as M spaces, but just for more generic regions of memory. So I guess I just never got around to implementing that, which is unfortunate. Let me just go ahead and real quickly double check that there isn't anything that I've missed. I would have liked to have demoed deep memory. I don't know if I have an older version of Moustache. Maybe I'll have to go look for one and see if I can find it. So I assume that the image markup stuff, I don't know if that stuff works or not either. I could have sworn this stuff worked. I'm creeped out right now. So here's one thing I will say for sure, is that I know that the pixel inspector would show all the transforms that stuff went through. And so at least with respect to the M spaces, you could print out all of the, and I mean, you saw this kind of working, but you could print out all of the transforms that it went through as you went through decoding a frame and just see them all listed, which was made it obvious where your bug was. I guess the deep memory version of that never got implemented, or I just forget how to view it, which is too bad. Anyway, so I think that's most of it. And like I said, this stuff just got stored. Take a look here. You would make a directory and then you'd just run it there. You can see these MRF files. This is the one where I let that thing start storing images. So of course they get pretty big pretty quickly. But that's all it is. And you could send one of these MRF files was a run of the program. So you could also send these MRF files around. And that was kind of nice. So if it broke on my machine, but if it was Jeff's code that was potentially the one that was causing the problem, I could just send him the MRF file and he could view it, and vice versa, right? So once you capture a run, it's yours to keep, so to speak. And so that was also really nice. You just create a directory on your machine and just let it fill up. You could even put in an external drive. Oh, whoops. Quit that. You could even make an external drive for it that just like, you had some huge, 2 terabyte drive that just sat there holding all the Moustache runs, and off you would go. What was the other file? There's an MWF file. Defaults.mwf. So I think that's everything. And again, I apologize the demo's not particularly smooth because I've forgotten how to use most of it and it was a pretty janky program. But basically all of those features, like being able to track things over time, automatically having everything, remember how to organize and lay out all your data so that when you run a program multiple times, you just get it again. The searching through the logs for stuff and then showing that so that you could always like pick out different things you wanted to grab. Like all of those things are features debuggers could just have. Like there's really no reason not to. And there's also no reason that the UI has to be janky, right? If you sat down and tried to figure out what a good design for the UI would be, I'm sure we could come up with it. It wasn't really the focus at the time, right? Because it wasn't a commercial product. But it's not like it's some huge, we'd have to imagine some great leap of computer engineering or something, right, to make that happen. I will go ahead and do a quick Q&A if anyone has questions about that. But I guess what I would say is that was just stuff that was made in the course of actually developing Bink. And so I'm pretty sure that it's not the kind of thing that would take that long to add to a debugger that currently existed. There are some architectural things that I guess are kind of hard that you have to make an investment in, like storing the complete state of everything all the time and all the source files and all the data that got outputted and all that stuff. That is some work. It's not that hard. And coming up with a good UI is obviously also something that would take some real work because that's refinement and polish and thinking things through in a way it's not about programming, it's about figuring out the right way to expose things to the user. So that's also its own thing. But again, the basic idea that you can just do stuff like, I have an array of vertices and I want to printf a log and say which vertex is affected at any time, and then later just see a 3D version of a model, pick that vertex and see the history. That is as easy to implement as what I implemented here for images, right? So this same concept that ranges of memory can just get tracked and then you just tell me what the range of memory is and I can go back and query all of these printfs, and the printfs can have things like 3D data or images or other stuff. it's all doable, right? And in not that much time, 6 months of work, you could do all of this stuff, right? And so I would just really encourage people to start thinking about how much power we could be putting into a debugger and that we're not, right? So, that's the situation. What editor do I use? I use 4Coder by Alan Webster. CallDVU. I've been wanting to get into helping write video codecs. I thought about contributing to AV1, but liboam is a big bloated mess and requires a lot of knowledge of VP9. Is there one you would recommend or would want people working on? So I'm not really a video codec person. I'm kind of the wrong one to ask about that. So I apologize. I only ever really worked on Bink, and I wasn't a video codec person. I did develop the half-pel filter for it. Was the one thing I did that was like video codec related, and it's a very good half-pel filter. I stand by my work on that one. But I didn't really do much else. I did the deblocking filter, which was okay, but it was really not that great. It was more about what we could do without taking any CPU time, and that's less relevant today than it was when Bink 2 was first made. Bink 2 was made to scale to like 4K in software on older machines, and so what you could do was limited. And this was on an Xbox 360. It also had to do 1920 by 1080 on that platform very cleanly as well, which is another hard thing because that CPU was not particularly powerful. Anyway, but ignoring all of that, I'm just not really a video codec guy. That's not my thing. And so I don't have a lot of strong recommendations about that. What I would say, right, is that I don't think the world needs a lot of work on the existing video codecs. I think what the world needs is someone to sit down and go, how do I make a video codec that's reasonable, right? Like it's pretty good, but that's like, 2,000 lines of code or something, right? Like, the problem with these video codecs like MP4 and stuff, like, or, that's more of a container format, but, like AAC and H.264 is, they're like insane. They're these huge, ridiculous, like massive investments in source code just to even look at all of the crazy cases. I was like, it would be nice if someone was just like, look, this isn't the smallest codec, it's not the fastest codec, but it's a codec you could use, like it produces reasonably small video that people could use, and it's like an H file, right, or something, Like that seems like the thing that the world could actually use, because, oh my God, like this stuff is insane. And because I think the world already has gigantic complex codecs. That's like MP4 and VP9 and all that stuff, right? And the world already has I want to pay a middleware vendor for a really fast codec that's optimized for every platform and has good support on everything from Android to PlayStation 4 to Nintendo Switch. That's Bink, right? And so it seems like the only thing I don't know is give me an H file that has a video compressor that sort of works. That's like decent. I don't know. I don't think there is one. It'd be nice if someone would make one. I just want to include some video in this thing. I don't want to think about it too hard. I don't want to build 18,000 files. I don't want to deal with all that. Pooh Shoes, do you envision using a single debugger or one for single single stepping through the program and another like Moustache with more complex views. I kind of want it all together. And the reason that I want it all together is that Moustache requires you to augment your code with calls to dump the data, right? But there's no reason you couldn't just ignore that and actually in your debugger take the stash f calls, like the things that say, here's what I want to dump. That could just be entirely in the debugger. I could just go into a line in the debugger and say, at this line, dump this data to my log. Then you never have to touch the program. And the program doesn't even need to include an H file or anything, right? It's just a program. Could be a program you didn't even write. Could be a program you don't even have source to. And you could say, when you get to this point in the program, dump this region of memory based off of these registers or something, right? And then you could have all the power of Moustache without even having to touch the source code, right? And furthermore, if that debugger stores run information, you could even go back in time and log data from a run of a program that didn't even have logging at the time it was run, right? So I feel like putting this into an actual debugger could be way more powerful than Moustache, even if it only supported the same features as Moustache. Having those features accessible from the debugger makes it more powerful, right? Have you tried the debugger? Let me go ahead and point this one out. I've heard of this one, but I don't think I've ever used it. I have never used it. I mean, I would be happy to try it. It's just that this kind of thing is usually not that necessary for debugging programs that you wrote. This is more of a like reverse engineering debugger, it looks like, right? So I don't know, like it's probably pretty cool, and I think it would be a good program to use potentially. I'd have to try it and see what I thought of it. But I'm suspecting that it's not really designed to do the sorts of things that I would do with a debugger, right? It looks like the kind of thing for reverse engineering, like you're saying, and reverse engineering isn't really where, like I don't need to reverse engineer my own programs because I wrote them, right? In what year was it made? Moustache, 2011, maybe? Marius AV, is it using regular GDI or GDI plus? It's using regular GDI. Basically, I wrote a complete like image system for it, which I can show you. It's not rocket science. So basically, here's the SIMD operations that I made. Like I made like a thing for operating on 4 wide floats in SIMD, and then what I did was yeah. Hold on a second. You'll have to bear with me while I remember. Where this stuff was. So when we did paint, we called into traverse display window. I think traverse display window. Might have been refresh display window. You know, let me go ahead and load. Let me go ahead and make a quick project file here. So I'm gonna put like I don't even remember. Hold on a second. I haven't updated 4coder on this machine, so let me go ahead and do that real quick here. So if I load up my 4coder custom layer, master.p, is it like master.text or something. Master.prj. All right. So if I make a master.prj, which we've never done on this machine yet, let me delete this here. I'm not sure how that works. It's just braces, right? Yeah, okay. So the projects that we currently have on this machine are like, you know, Handmade Hero, and that's in handmade.proj. There was Handmade Ray, and that was in Handmade Ray.proj. And then there was, you know what, I don't know. There's Meow Hash, which was in meowhash.proj. So it looks like that's everything. And then I'm just going to add Moustache, and I'll put that in here, and that was in apps Moustache, and we'll just call this mustache.proj, I guess. That seems, I guess, good, maybe. Yeah. So then inside Moustache, I'll just make a project file for it, and that way I can load everything up and do searches and stuff like that. So if I do a mustache.proj file here, I don't really remember how this works, but it's something like this. And there we go. So now I should be able to do like searches and stuff so we can look at that source code. So let me go ahead and switch project here. Shouldn't that have... Did I mess it up? Again, you have to forgive me. I'm in the middle of doing a bunch of changes to 4Coder, so I'm not really ready to do stuff like this at the moment. But I did make I made a wmaster.prj, right? Did I organize it wrong or something? It's a string constant. There's a name and a file. I mean, I feel like that should have just worked, right? Oops. It looks right to me. But I guess not. It's gonna read wmaster.proj, but that's good. That's what I want. It's gonna tokenize it. It's gonna look for an open brace, string constant. Oh, yep. No comma. All right. So maybe now I've done the right thing. Yeah, there we go. All right, so if I load Moustache, now I should be able to jump around everything. So, I don't know, let's see here. Here's that refresh thing. Okay, so is it traverse display window then that we were doing? Yeah. All right, so in traverse display window, we should be able to look at some of that drawing code now. And I'm going to look out, I'm going to see if I can find something that looks like it's doing some drawing, and then I'll show you what that code looks like, so you were wondering about how it was running that fast on just straight GDI. So let's see here on something that's going to render like an image source. So here's the image node, right? And let's see, it's got inspect work, create work. render work. So blitz scaled. So that's something that's dealing with an image, right? So here's blitz scaled, and here's what that routine looks like, right? So, yeah, all right. So basically, what you can see here is I do the basic setup work, right? I look here to see if I need to do aspect ratio scaling. Oops, sorry about the swearing there. We'll just scroll that off. Unlike on Handmade Hero, where I'm trying to be clean, when I'm working professionally, I swear all the time. So anyway, in the code here, you can see me setting up the image transfer, and then I've just got two functions that I wrote. One is blit 1-to-1, which does an exact copy. You can see it doing it here. And then there's blit sampled, and there's some more swearing. And you can see that working here. And what you can see is they're all just SIMD code, right? They're just like, hey, let's just process for 4 color values at a time, right? RGBA. We load those in and we write them out, right? And I think, I mean, yeah, if you just write this stuff sanely using dib sections through regular GDI, just SIMD is very fast, right? I don't even know if this is multi-threaded. I mean, it might have been, but I don't know. I guess I can find out. No. So it wasn't even multi-threaded. That was single-threaded performance. It's just if you write SIMD routines and you do them reasonably smart, you can just do it. How long did the project take you to write? I don't know exactly. It was at least 6 months of full-time work. I don't understand why using GLDX is not an option for an internal tool like that. Well, the reason was stability. So Jeff just didn't like what OpenGL would sometimes do in terms of multi-monitor support or destabilizing a system because the graphics drivers were bad and so on. Since this entire thing ran on the CPU, you could guarantee that it was not screwing with your graphics card at all. And all that had to do was if GDI could just manage to get the buffer to like get handed off to the graphics card, that's all it had to do. That was why the decision was made. Wasn't my decision. That's just why it was done that way. And no, it was not ever supposed to be released. Why did you not name this Moustache? I don't know. It's a good question. Will you upload this to YouTube? Yeah, probably. And also, I turned on archiving on the Twitch stream now, so you should be able to get back to those. Are you still giving feedback to the Win Debug Dev team on Twitter for where it's still lacking in its current state? Did you still like it better than the VS Debugger? So 2 things. One, I was a little nervous about the feedback situation because a lot of the responses from the WinDBG guy, it kind of sounded like they weren't really that interested in making it work well. I'm like, you know, there needs to be a hotkey for setting a breakpoint. And they were like, yeah, we used most of the hotkeys that we have available or something. Like, they were weird answers that kind of sounded more like they had a particular way they wanted it to work and they weren't super interested in necessarily like feedback on like, hey, there really needs to be a hotkey for this. Like, it's important. Maybe make rebindable hotkeys or something if you have a different opinion about what needs to be hotkeyed, but like, you know. So it seemed like maybe they weren't that interested in feedback. They were only kind of like interested in minor feedback, like there's a bug, it crashes here or something like that. So I'm not super optimistic. What I will say is I do like it better than Visual Studio's debugger from the following standpoint. It doesn't install SQL Server on my machine, for example, right? I just copy the directory and it works. If you actually want to use Visual Studio's debugger, it installs massive amounts of unnecessary things on your machine, requires licensing to run that can just stop working at any time without your knowledge and without you necessarily knowing why. Even when you're a paying customer, this happens. It's just not good, right? And so I don't like the experience as much as using Visual Studio, and I'm not really super sure, based on what I kind of heard from the WinDebug people, that they're really all that interested in making it good in that sense. But because it is usable and isn't an epic disaster, that makes it better than Visual Studio in terms of just what I'll learn to live with, right? And the hope is that, someday RAD ships one and then I'll just buy that and I'll use that, right? Because there's so much better debugging out there to be had, and we just need that to come along. But really, that's the main thing, is just WinDBG preview is usable. Like, I can debug with it. And so I think I just would rather do that than have to deal with Visual Studio, because Visual Studio is so broken at this point. Did you add those new features to 4Coder? Yes. During the stream, Ryan Reese said, I'm still on the fence about that unusual interpretation of the compilation model. The everything is in this header file. I'm interested if there are any downsides to it. Well, I guess what I would say is I don't necessarily know that everything needs to be in a header file for everything, right? Just something like this. If you're talking about something that's just designed to be a debug port, then yeah, of course it should all be in the H file. It should be a tiny H file. It should do everything, right? Because it's the easiest possible thing to include into your program, right? That doesn't necessarily mean it's right for everything. It just means for this sort of thing. I can't think of any downsides to it, and if there are, they're drastically outweighed by the simplicity of just being able to copy one file into your project and then be done. You don't have to worry about linking, and you don't have to worry about DLLs or copying things around with the executable. You don't have to worry if somebody changes it. It's not going out to a website to do something or any of this other garbage or package managers or GitHub or any of this other stuff. It's just, I had an H file, worked, I copied it into my program, I was done, right? And that's very good. I think C64 debugger had a pixel to code feature like Moustache. I don't know what C64. Oops. I don't know what C64 debugger is. Oh no, I've lost my earpiece. I gotta put a new earpiece on. In fact, why don't I just do that now? Do I have the earpieces? No, I don't. I need to do that because this earpiece got so loose that it just comes out all the time. I need to get the new one for it. What I was going to say is C64 debugger, I'm not familiar with, but what I can tell you is there are graphics specific debuggers which do some of the Moustache stuff. They're not quite the same because they don't really allow you to printf arbitrary data out to it, I don't think, but maybe they do. But for example, Pix, P-I-X, the graphics debugger from Microsoft that was for DirectX debugging, it would at least allow you to see everything that touched a particular pixel in the graphics output, right? So that's something. And that was similar. Did you use GDI functions for stuff like spline drawing, or did you do it yourself? I feel like I would have called GDI if it had it. Because why would I have written it myself? So for fonts, I think I just called GDI to draw the fonts because it could do that, right? Fast. It can't deal with images fast very well. At the time, anyway. Let me see if I got any. What else I got here? Why do some functions use the and not pointers? Yeah, I used to use references more. And here's the thing. I don't think C should have dot and arrow. I think that was dumb. And so I used to use references so I could just use dot everywhere. But then eventually I was just like, forget it. Like, I might as well make my code like basically C compilable for C99 and just use pointers. Like, why not? It's just, I'm fine with it, right? So I used to still use ampersand for that reason. And I wish that they just would make it so that dot worked for pointers, but you know, they don't, so. Oh, like the vertical text on the left in your FurCoder build is really cool. Is it available in FurCoder or is it your own customization? That is my own customization. The FurCoder stuff that I've done is pretty advanced at this point. So one thing that you'll notice it now knows is it knows when things are functions or types that are user defined, for example. I implemented that. Yeah, the stuff that says like what if block you're in, if it's off screen, and what function you're in and stuff, like that stuff here, I implemented all of that. Also this jump thing I implemented that like finds everything in your program and allows you to jump to it. The project switcher, all that stuff. So I implemented a ton of things over the past 2 weeks when I was back from break but haven't been back on stream. None of it is possible to share with you at the moment because I had to modify the FurCoder core to do it. But I have resubmitted the changes back to Alan. So at least in theory, at some point, you will be able to have these features. That time is not now. But when Alan has a chance to integrate my changes into his code base and he ships a new FurCoder, then you could have the changes. I also did some other stuff like search now works. So, you know, when you do like size of, it'll highlight all the ones in the view, you know, stuff like that wasn't working for. I also added a feature that's super crazy. I haven't finished some of it yet, but I'll show you. It's really strange. So let's suppose you're in here and you want to do some math. Basically, this was because I was really tired of this garbage, like having to go to some other tool to do math. I was like, I don't really want to have to do that anymore. So what I did was I just made it so like, oh, okay, you know, if you're in a comment and you want to do, I just want to know some stuff, I can just do it. So if I want to know what how many pixels there are in 1920 by 1080, right? I can just do it and it just tells me. It just does the math for you, right? And so if I want to know like how many bytes that is, I can do it that way or something. And well, okay, maybe not. Why is that not? Clearly, I have broken something. All right, so again, like I said, not quite done yet. So that's weird. This stuff was working on the other machine. I wonder what. Something must have broke with comment lexing. What's going on here? Sorry, this is not really what I was supposed to be doing on the stream. Interesting. So something broke with comment lexing, but I'm not sure what it is. So I guess I've got a new bug I gotta go look at. But anyway, it has all the basic stuff in it. So you can also assign variables. So like if you want, you can do that. And so then like in here, you can do that, right? You know what I'm saying? And so the idea there is just that from then on, I can just make it so that I don't ever have to switch away anymore when we're doing that stuff on stream. I can just put it into the comment. And the nice part about that is it can remain in the comment. So it's just there. Like, we're like, oh, this is when we did that thing. And here's the answer. And then I don't have to, like, deal with it anymore, right? Why this Lexer thing is not working properly, I'm not sure. So I gotta look at why that is. And furthermore, it's a little bit weird because it looked like it was not even sensitive to what else you might do. So I'm not sure how that's possible. Yeah. It's very interesting. So something's weird about that, but I really just don't know what it is. It's like it only wants to Lex that one. I have no idea what's going on there. That's going to be an interesting bug to find, I can tell you that right now. Is it just 5 times 5? Is it just that there's a bug? You know what it probably is? There's just probably a bug in the multiplication term parser where it's not asking for an add term next to it. So it's probably just the parser. That's all it is. Yeah. It's probably just the parser's busted. We'll fix that later. So yeah, ignore this for now. It's not really ready for prime time, but it will be at some point. And yeah. Don't ask me why it's busted. I don't know. Probably the parser's messed up. Let's see. We should probably change it to shunting yard anyway. I think right now it's actually was building the actual parse tree or something stupid like that. I don't know. It's a long story. How would you port a game from Windows to Mac OS when the code base is in C? Any resources to share? Thanks. Yeah, I know. So it's weird, right? It just doesn't look like it doesn't know what to do with concatenated multiplication. It's very strange. So like that's correct, but that not only it just can't figure it out. It's like I don't know what's going on. So I think the parser is broken. Is what's happening there. So we'll have to look at what's going on there. I don't know what is happening. Yeah, and again, I don't even know if parentheses work or not. Yeah, it looks like they work with parentheses. So it looks like it's just the parser for the term for the multiplicative term is just not doing the right thing after it. Oh, the colors I haven't tuned yet. The colors are garbage. They're just debug colors to make sure that I was seeing the right thing, but All right. No, it's not a problem with the asterisk being part of a comment. It's just gonna the parsers. Parser is crap. It just got kind of threw it in there. The math expression parsing is extremely cool. Can I implement it with the current customization layer, or is it only possible with the source available? It's only possible with the source available, not because of the parsing. You could do math expression parsing because I implemented that myself, and you could do that. You could have done that yourself. But the problem is twofold. You don't have a way to actually know when you need to reparse the buffer. I added that. And the other thing is you don't have a way to draw text that isn't part of the buffer. And I added that. So those things there, right? Because remember, those aren't there. So if you now go back and look at the file, right? So that file was something like stb ping test.cpp. Right, it just saves that, and it doesn't insert the answers, right? They're just floaty phantom answers. Yeah, no, the colors aren't permanent, don't worry. The colors are just there because I was trying to debug. I didn't have a chance to actually go tune the colors, and I was just trying to make sure that like all my parsing stuff actually worked. Right? Anybody else? We're all good? Oh, right. Someone did ask a question before. How would you port a game from Windows to Mac OS when the codebase is in C? So, you know, a lot of that just depends on how the code was written originally. So, the way I try to make code work across platforms is I try to isolate all of the parts that are actually specific to the platform. And you know, Handmade Hero, we've done that very specifically. You can go look at it and you can see how it's very walled off. You're not allowed to have any Win32 code outside of the Win32 file, you know? And that's the way that I do things. So the first thing I would do if I had to port an existing game from Windows to Mac OS is I would go through the code on Windows and try to pull out all of the Windows-specific stuff into its own separate area, like its own separate file, that I could then replace with Mac OS versions. That's how I would go about it. You know, there's not a lot else you can do, but that's a good way. Very similar to that, one good way to port something is to say, all right, isolate all the Windows code, then on Windows, still not on Mac OS, go get SDL2, right, the Simple Direct Media Layer 2, write an SDL layer that replaces the Windows layer so that you can still compile it on the Windows layer you isolated and on SDL2 and run it on Windows under SDL2. And now you know it runs under SDL2, which also runs on Mac. Now you can move it over to Mac, compile it with SDL2 on Mac, and get that working, and off you go, right? So you can kind of go through these stages of like isolating the parts that were actually specific to Windows, right? When will you cover the Raspberry Pi? Well, we won't really do anything with other platforms until the game is done, right? Like when the game's released, we will then go and look at other platforms like Raspberry Pi, which I don't know what... It might not be the Raspberry Pi if that's not the most appropriate platform at the time. I'm assuming it still will be, but like we'll find whatever the most appropriate, like, you know, single board little computer is, and we'll look at that, which will probably still be a Raspberry Pi of some kind, the Raspberry Pi 5 or something, you know. But if there's some other thing that's more popular at that time, we'd do that other one instead. Do you know how the calendar and date are implemented in games? I'm not sure what you mean. Do you mean like, are you talking about like games like Animal Crossing that try to do like different like special things on Halloween or something? Nathan Dirth, I've heard a lot of people complaining about C++, which has me worried and looking into other languages. Is there any problem continuing to use minimal C++ like you do currently? Can new C++ features hurt you? I think it's probably relatively safe to continue using minimal C++ like I do. I'm certainly not too panicked about that specifically. I guess what I would say is there are two costs associated with C++ that, I mean, certainly worry me, and you are right to be worried. And they are as follows. Number one, because C++ is designed primarily by people who don't actually, you know, do real game programming for a living, they don't tend to add the features that are necessary for real game programming. And so at the moment, C++ is lacking many features that you would obviously have if you were trying to make a language that was good for this. If you contrast C++, which has had 30 years to make these additions, to, for example, JAI, which John has been working on for only a couple years, you can already see literally hundreds of features that he has added that C++ has not added. And again, the difference there is you've got a working game programmer, one who's very good, making features for what they do. And so the biggest cost of using C++ is a language design paradigm and process that basically doesn't take your needs into account, right? So that's the biggest problem, right? So as a result, every year your programming gets worse compared to what it would be if you could have a language that would add features that were necessary to enable you to write better code faster. So that's a huge issue, and it's been happening for a long time. So it means that if you compare what your code quality should be today under a C++ that was guided by, you know, design principles along that road versus what they did choose to do, you know, the difference is kind of somewhat staggering. If we were actually to think about what we would have today, if it had been shepherded in that direction. So that's very concerning because it does mean that there's a lot on the table, and it also means that your ability to write effective code compared to, say, working in other languages that were maybe were shepherded better, like C# or something, you take a hit. And so as a result, you know, there's reasons why you might not want to use C#. I mean, I don't use it, right? Because I don't want the extra layers of indirection that are inherent there, and I don't want to have to worry about certain aspects of it and so on. The problem is every year the C++ community continues to make bad language design decisions, you get further and further behind languages that might be making better decisions who have problems because they weren't rooted in a systems programming language to begin with, but they're getting better and we're getting worse, right? Because of the design decisions. And that's a really bad situation, right? So that's thing one. And thing two is that even though you don't have to use the poorly designed features that are coming into C++, they do hurt you in one very important way, which is they are complexity that gets put into the compiler, and that complexity yields more bugs for you, right? Because the amount of effort that's put into the compiler is finite. There's a certain amount of work getting done on Clang, and a certain amount of work being done on Visual Studio. Because those implementors must implement the poorly designed C++ language features as they come out, that is time they're not spending debugging the optimizer, improving the optimizer, debugging the debug info, debugging the code gen. All of that is not going into giving you an improved product because you're not using the C++ features, right? So there are definitely two very real ways that the poor design direction of C++ affects everyday programmers who, know better than to use it, but in the sense that you can still write C code and it compiles properly, you're not hurt that much in that sense. My hope is we won't keep having to have this discussion. My hope is that we can reasonably move on to JAI or something, or there will be more languages coming about with a system programming angle to them, and C++ can just go off and die in a corner, right? Like, I don't think it's productive to constantly litigate the C++ thing. It's not a good language. Let's just accept that. It's not going to be a good language. So let's just focus on what will be. Like, let's try to get to something that is, right? And then people who think C++ is good for some reason, you can still use it, right? It's still there. But those of us who don't think so can have something to move to. That's what we really need, right? What we really need is an alternative, because sitting around complaining about C++ isn't really going to help. We've been doing it for 30 years and it's never gotten any better. So, like, what we need is a way to move to an alternative that we can contribute to and make good. Would you say that the Handmade Hero platform layer for Windows and OpenGL is at a shipping state now? I mean, I guess what I'll say is games have shipped on worse, probably. But is it the ideal thing that you would ship with? Definitely not. So, it's probably possible to ship a game on the Handmade Hero platform layer, but I wouldn't recommend it because we haven't done some of the finishing work that you would want to do for a final product. Even just basic things like keyboard layout support and stuff like that we haven't really addressed. And so I think in order to have a quality experience, there's things we would want to add. And there's notes to that effect in our platform layer at the moment, in fact. Do I have an opinion on Rust? No, not really. I haven't programmed in Rust. I've added some fancy file functions to the platform layer, notify whether a file has changed, etc. And for every new function, I just added it to the platform API struct. Is it that simple? Yeah, it is exactly that simple. How's 1935 going? Pretty good. I've had to divert some attention because Meow the Infinite will be launching soon. But pretty good. You will hear, hopefully, more about it in the not-too-distant future. Have you ever used embedded Lua? Do I have an opinion on LuaJIT? No, I don't. I have not used those things. For programmers, what do you think skill is most... What skill do you... Okay, I see what you're saying. For programmers, what skill do you normally think is most commonly lacking? And are there any practicing methods people should use to become better programmers? Yeah, I mean, I think I've sort of answered this before, but it's pretty easy to summarize. I think the primary problem is that people don't actually look at the results of their coding practices. That's really the thing that I would like most people to do. I mean, dovetailing onto the previous discussion about C++, that's my criticism of that language design as well. People aren't taking the results of their programming practices seriously. They're not looking to see whether the things they claim prevent bugs actually are preventing bugs. They're not looking at whether or not they get more code done that has less bugs in it in the same amount of time. There's just a lot of things that are sort of stated as fact, but that have no actual basis in reality, and that's a problem. And I think what every programmer can do to help themselves get away from that is to just actually look at your actual, when you adopt programming practices, look and verify that they're actually saving you time, that they're actually catching bugs. Don't just type const into your code. See if you're actually having bugs related to modifying things that you're not supposed to modify. If you're not, then you're wasting time with that, right? And those are basic things that everybody should do. Everybody should know at this point, if you're an experienced programmer at all, where do your bugs come from and which programming practices actually help catch them and which don't. Because it's different for everybody. It's not the same. When people say that this is a good programming practice, that's usually ridiculous, because usually at best it can only be a good programming practice for a particular programmer or for a particular team, right? But I would say in general, like, that's really the thing that programmers should focus on, that they focus on the least, is actually assess, are the practices that you're doing helping? Are they doing what you thought they were doing when you adopted them? And it's really important to understand that there's just a lot of dogma in programming, and it's not useful, right? And so when I talk about things that I have found to be good programming practices, what I'm talking about are things that I've found are effective, and I've looked at them and they save me time relative to the alternatives, right? Even that is not good enough, or shouldn't be good enough for you. You should be taking the things that I say and say, oh, okay, Casey thinks this is good, so it might be good, but maybe my brain doesn't work that way. And maybe it doesn't help me to do that thing. And so what Casey's saying to do is really just a waste of my time, and this other thing works better, right? Learning to be able to do that analysis is critical, because it's totally fine to go look on the web or listen to this stream or do whatever else to learn about the possible techniques you could use, because other people are going to have thought of things that you won't think of. But what's not fine is assuming that they're right just because someone on the web said it, right? Because that doesn't matter. Like, we don't have the kind of science right now necessary to prove that a programming practice is good or bad. And furthermore, I suspect it differs from person to person, right? Kind of like what diet you should eat isn't probably universal. Like, people from, a particular country, a particular genetic lineage probably want to eat a different diet than other people, because humans are different, right? And programming is the same way. The same set of techniques is not right for everybody, and you want to learn how to actually assess how you are programming, and then you can test out these techniques to find out which ones I use are good for you, which ones someone else uses are good for you, and that's how you become a better programmer. How do I become a bigger programmer? An excellent question. It's difficult. Question on the Discord: how are your compile times so fast? I've compiled shorter programs with similar linkage to Windows, and others are saying they are compiling Handmade Hero on a PC with an SSD and getting quite slower compiles. Is your computer just that much faster? I mean, it depends on the SSD drive, potentially, or the computer. This is a pretty fast computer, this one. But I don't know. I mean, one of the big problems with Visual Studio is you don't get much of a build profile out of it. I don't know if there's switches now that you can get more of a build profile, but it's kind of hard to know where the time's going. C-time tells you the time for any individual step of your build, but it doesn't really help you profile the internal, so it's kind of hard to know, if Visual Studio compiles at a certain speed on one machine and on a certain speed at another. It's hard to know exactly what the slowdown is. Is it, related to this or that, Ginger Bill says, the issue is that the vast majority of programmers don't know anything about the scientific method or learning from empirical data to improve their skill. If people actually treated computer science as an actual science, it would help a huge amount. I would broaden that to not just include programmers. Most people don't understand the scientific method. They don't understand that when you call something science, that's just an arbitrary term. Only things verified by the scientific method are actually true, right? Or I shouldn't say true, repeatable. And repeatability is what you actually care about in the world. And so there's a tremendous number of things also that are branded science that aren't science, because, at least in my mind, they don't follow the scientific method. Scientific method is the only thing that actually matters. The word science is irrelevant. Scientists are irrelevant. It's only if you've done the scientific method to its completion that you actually know anything, right? And the same is true of programming, right? And unfortunately for programming, I would say we're pretty far from being able to really apply the scientific method for real, right? So you can only really do kind of a loose version of it anyway, but you should try as best you can to actually do experiments and see what the results are to the extent that you can. But I would say that one of the big reasons that computer science can't really touch a lot of areas that we would like it to is because the scientific method just really can't be applied really in any way that we know about yet. How do you reason with people heavily invested in programming dogma? I don't. I just don't work with those people, right? Do you know of a way to get rid of order dependence in C? I thought about actually parsing the code, but that seems quite annoying. That's the only way. I wish there was a way in C to fix that, but as far as I know, there isn't. I wish C had a function keyword. I think that would have solved just about everything. But unfortunately, function keyword and maybe a different casting syntax, and then it wouldn't have been really a problem, right? You wouldn't need forward declaration really, and stuff would have just worked probably. But it didn't, and it doesn't. So that's just the way it is. Again, same thing. C++ could have fixed this. They chose not to. They chose to focus on all these other things that don't help. Hopefully, again, there'll be different languages in the future, like JAI doesn't have order dependence. That's a great start, right? Do I have an opinion on the overuse of virtual methods in C++ and the vtable overhead? Not really. I don't have a problem with virtual methods and virtual tables as a concept, because that is one way you can do dispatch tables. My objection to the C++ version, as with everything in C++, is it wasn't implemented properly. It should have been implemented as an optional feature that you could enable. You could say, I would like you to construct a virtual table. Here is the things I would like to put in the virtual table. And here is the member that I would like to use to point to it, right? That would have given you the ability to have multiple virtual tables per struct if you wanted to. It would have given you the ability to have copied the virtual tables around. It would have given you the ability to store an integer and to use that to look up into the virtual tables, so that you could have had RTTI implemented in your code rather than in C. Again, my complaint with C++ is almost never about the thing that the compiler is generating. It's that that thing was not interfaced properly. The same is true with virtual methods. It was just a poor design. All right, I'm gonna wrap it up soon here, but we got lots of questions. I heard that in the classic Serious Sam game, they implemented the multi-gravity for the player to move along the walls. Do you know how the multi-gravity works? I'm sorry, not familiar with Serious Sam, and I'm not sure what multi-gravity means in this case. What is your opinion on formal verification? Do you think there are any applications of it in game programming? I guess I don't know. Formal verification is certainly interesting, but the problem with it is that it's pretty limited in terms of what it can actually verify a lot of times, and it tends to not be really great with user input. So the kinds of things that we might want to ask regarding the kind of things that we might want to formally verify in games tend to be very hard to verify. So it's tough to say. What I can say is the broader idea that algorithms can be written that foreclose the possibility of bugs, I do think has a loose application in games. I would point you to the collision detector I wrote for The Witness as an example. That was an algorithm specifically designed to make it not possible to have movement bugs at a certain layer of the game code, and I think that worked very well. Again, it's not technically formal verification, but it's a kind of verification or a kind of formality that can be imposed on the code in a looser sense that does have a lot of applicability in games. So, as a partial answer to your question, there's something. The DMD compiler can tell you which lines of source code take the longest to compile. So unsurprisingly, it's mostly templates. Yeah, unsurprisingly. All right. Looks like we are done. I'm going to go ahead and wrap it up. Thank you, everyone, for joining me for this special presentation of Moustache on Handmade Hero. I will be posting stream schedules soon. I'm not sure exactly what we'll be doing stream-wise. I may try to stream some of the 4-coder development that I've been doing because I'm finishing that up in the next couple days. I may try to stream some of that, in which case I'll be back pretty soon. If I don't decide to stream any of that, I may not be back till next weekend. We'll see. But I'll be posting a stream schedule fairly soon as I figure out exactly when the streams will be. So stay tuned for that. And again, they'll show up on this Handmade Hero watch page here. When the stream is not live, it puts a little schedule there for us so you can know when we're going to be live. There's also, of course, the Handmade Hero Twitter feed, but Twitter's kind of a disaster, so just use the watch page. That's about it for today. Thanks for joining me. I hope that anyone out there working on debuggers can maybe think about adding some of those Moustache features to their debugger, because there's a lot of good stuff in there, but it's kind of not really useful for the majority of the world at the moment because it's just in this little internal RAD tool, and it wasn't really polished to the point where it could be easily accessible by people either. So I feel like getting that stuff out into sort of the real world, it would be pretty good. So that's it. Thanks for joining me. I will talk to y'all next time. Until then, have fun programming, and I'll see everyone on the internet.